Boom. All right, so guys, so normally if you've been in my class before and you had, and I've been doing some of these videos, I like wearing different hats. So you guys get my cool yellow rally cap hat here. I'm gonna stop doing the videos the way I was doing them. I'm going back to the way I used to do them. I like it better that way. So today we're gonna be tackling 11-1 part 3. A couple of things I want to do real quick is we want to review and finding the angle. That makes that one's a little bit tougher because of the use of the calculator. And then the other one is applying trig functions to real world applications. So this goes with, I believe, page 649, 37 through 49, and this is review. So it's page 649, 37 through 49. It's your trig assignment number 3. So let's just talk about this review piece first. Let's talk about finding the missing angle. So we're going to do find the missing angle. So if we're finding the missing angle, we need to have a graph of it. So we need our picture. We have our numerical, which I haven't been using a lot yet. All right, and then we have our given, and we have our given, and we have our algebra. So we'll break it up into those. So I'm going to draw the triangle for you guys. The triangle is this. We are given a right angle here. We're given an x value there for that angle, and we're given an 18 and a 27. So this is words, actually, sorry. Words, gnaw, G-N-A-W, gnaw. We're gonna gnaw on the problem. So here we go. Words, what are we given? We are given theta, that one. That's what we're looking for. It's our reference angle. We don't know what that is. So we're looking for that one. Across from theta, we're given our opposite. Our opposite is 27. Next to theta is 18. So that's our adjacent is 18. So we're looking to find this guy right here. So that's step 1. We drew what we needed to. We've labeled the sides. All right, so now step 2 is going to be, what trig function do we need? Well, theta has a relationship to opposite and adjacent. So we know that it's opposite and adjacent, and that relationship is tangent. So, and that comes from SOHCAHTOA. Tangent, opposite over adjacent. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. So we've got this equation. So we're going to algebra. Giving us the green light for algebra. So we know that it's tangent. Tangent of what? We are not sure. And we are looking at opposite over adjacent. So now what we have to do is we have to get this x by itself. And how we do that is we take, rewrite this here real quick. We take and use our inverse tangent to both sides. Not very clean writing here. So then we got our inverse tangent. What happens to our tangents here? They disappear, and we get x in degrees. We plug this into our calculator. Tangent, inverse tangent of 27 over 18. You can either use your calculator or use Desmos. I can't remember which one I used, and I got a value of 56.31 degrees. So that's my angle. Goes right here. 56.31. I did not use Okay, so I did not use that one. So we've just reviewed how to find a missing angle. I'm given two sides. When I use two sides, I'm looking for a missing angle. So I'm going to use my trig functions. All right, so I'm going to erase that one. And we're going to tackle. So we got that one done. Applying trig functions. So I'd get out your book, get out your book, and look at real work example number 6. I don't know what page that is on. I'll look right now. It's on page 646. I'm going to explain that one to you guys, break it down a little bit better for you. So we are given, again, I'm going to draw it a little bit bigger. So this is example number 6. And I said it's on page 646. Page 646. So we need our graph. So we need our graph right here. What's our graph look like? Our graph looks like this. So it talks about a golfer who's hitting a ball up to a pin or a hole. We'll draw the hole here. A hole that's 36 feet above it. So if we draw the triangle, it looks like this. So here's the thing about trigonometry. Let's assume the golfer is on a hill and the hole is right here. They want to know the distance between the ball and the hole. So that should have been a straight line, but it happens. Probably the hat. So let's just look at this as a triangle. It doesn't matter that there's a hill and he's got to hit the ball above it. It just matters the distance, the straight distance to the hole. So we're looking for that piece. We just need the other angle, and that angle is 12 degrees. So let's look at our words here. What are our words? Our words, we are given, what are we given? We are given theta, which is equal to 12 degrees. We are given the side opposite, which is equal to 36 feet. And we are looking for the distance between the ball and the hole, which is here. So we don't know what that is. I'm gonna write D for distance, and that is our hypotenuse. So our hypotenuse is D, the distance to the hole. To the hole. All right, so if we look at the distance to the hole, now we've got all the pieces that we need. We have a relationship of opposite over hypotenuse. So we are given the green light to go to algebra. Algebra. We have a relationship of sine of theta is opposite over hypotenuse. Opposite over hypotenuse. The sine of theta. Oops, what's theta? Theta is 12. What is opposite? It's 36. What is hypotenuse? It's D. So I'm looking at this, going, okay, I have a ratio. I can make this a fraction. Let's clean that up a little bit. So bottom left times top right goes on the right. 1 times 36 is 36. Bottom right to top left goes on the left. Sine of 12 degrees. It can go either way. As long, this can be over here and 36 can be over there. I just like to do it this way. It's my personal preference. What do I have? I have multiplication. So we're doing SADMEP backwards. We have a multiply, so we clean it up by dividing. Those simplify out to 1. And my D, which is what I'm looking for right here, D is equal to 36 divided by the sine of 12, which is going to give me 73.2 feet. All right, guys. So this is going to become approximately 173.2 feet. One little piece right there is 2 feet. All right. I didn't use this again. I didn't use numbers. All right. So go ahead. You can do the guided practice on 6B on page guided practice 6B on page 646, which is right here on the bottom. It's about ladders. If you want to do that and check yourself, that answer to 6B is 13.3. So if you want to practice one, that answer is 13.3. So it's about 13.3 feet. Practice 6B. It's right at the bottom of page 646. It says ladders. All right, so that's another example for you. So now we have one more bonus example, and it has to go with the last question of the day, which is number 49. So we're going to move through this. Haven't talked in a while. So here we go. So you are given this crazy looking triangle. I'm just going to write it up here for you. And it's A, this is C, this is D, A, and B. This angle here, this big one, is 75. This angle here is 47 degrees. And the height here is 150 feet. All right, so question is, how far apart? Question is, how far apart are those? That's the question of the day. So let's just kind of look at that. All right, so how would I tackle this? Well, I would definitely do a knob problem. This is a little big. So I'm going to clean it up a little bit. You have two triangles here. You have triangle 1, which is C, D, and A, 150 and 47. So I broke that up. Then you have triangle 2, which is C to B to D. And that angle is 75. And its height is 150. They both share the same side here. So we need to find AC. So we need to find the distance between A and C. And we need to find the distance between B and C. Okay? Why? Because this is my graph part. Because numerically, here's where numbers come in. Numerical, or numbers. I'll just say numbers. Ooh, I can't spell numbers. Numbers-wise, how do I find the distance? I subtract the total. I take the total length, and I subtract the smaller piece, minus AC. Okay? And that's going to give me the distance apart. So I need to come up with those numbers. So let's just take our words here and let's clean it up. So our words, we're given what? Triangle. That means triangle. Triangle number 1. This is triangle number 1. Triangle number 1, we're given theta of 47 degrees. We're given a adjacent of 150 degrees, and we're given to find AC. We don't know what that is. All right, so then we have given, I'm running out of room here. I know, because it's right here on the edge. Given triangle 2, hopefully this comes up. So listen carefully. If it doesn't, my angle is 75, and my adjacent, it's not degrees, 150, and my distance is BC. So let's tackle these in their colors. So here we go. I'm going to slide over here like this. So we're looking at triangle 1. So here's my algebra. Triangle 1 is going to be the opposite. Oops. This is opposite, right? So this is opposite. We're going to do tangent because it's opposite and adjacent. So the tangent of 47 degrees is equal to AC over 150. So that means AC's length is the tangent of 47 degrees times 150. All right? That's going to be 160.86 feet approximately. That's the length of AC. So now we're going to do triangle number 2. Triangle number 2, we have a theta of 75 degrees. We have an opposite of we don't know. We have an adjacent of 150 feet. Multiply that times that gives us our length of BC, and then our length is going to be, once we plug it into the calculator, Desmos, whatever calculator you want, is going to be 559.81 feet. So BC, 559.81 feet. AC, 160.86 feet. Hopefully that made it in. And my answer, 550, 160, so is approximately, I didn't do the math on this one, I don't have a calculator near me, so that's 560, 160, it's approximately 400 feet. So this is approximately 400 feet apart. All right? Okay, guys, there you go. It's the new way to do it. You guys got my new hat. We're good to go. We'll talk to you later.